The fact that integrating 1 over x gives log of x is a really important result, and we'll justify it here. And we'll do it backwards by differentiating log x and proving that you get 1 over x. So in order to do that, notice the following things. Firstly, if y equals log of x, then x equals e to the power of y, and they are two equivalent statements containing the same information, just one is y expressed as a function of x and the other is x expressed as a function of y. Now we want to find out what dy by dx is because we're trying to differentiate y equals log x and prove that it turns out to be 1 over x. We're going to differentiate both sides of x is e to the power of y with respect to x. And in order to do that, we need one more trick, because the right hand side of that equation is expressed as a function of y, and yet we want to differentiate it with respect to x. And in order to do that, we use something called the chain rule. And the chain rule, simply put, is this, so that a function differentiated with respect to x is the same as that function differentiated with respect to y multiplied by dy by dx. And as scientists can go around life thinking about that as similar to multiplying fractions, and you can kind of cancel out the dy's and be left with df by dx. A mathematician would probably go crazy at that point, but it will probably do for us for now. Now, that being the case, let's apply that to the expression x equals e to the y and differentiate both sides with respect to x. Now, differentiating the left-hand side is easy because if you differentiate x with respect to x, you get 1. To differentiate the right-hand side, we then use the chain rule, and so that's the same as differentiating e to the y with respect to y, which is just e to the y, multiplied by dy by dx. So where has that got us? Well, that's quite easy now because e to the y is the same thing as x. So we have 1 equals x times dy by dx, or in other words, dy by dx equals 1 over x. And that's a really important result, as is its inverse, because if we differentiate log x and get 1 over x, then that means that integrating 1 over x gives log of x. And one tiny final thing, notice the modulus signs around the x in the integral, just because log of x is not defined for negative values of x.